Oke, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, good afternoon. Thank you for this opportunity. My name is Muhammad Tentang Pamil Ilmi from Universitas Plus Maret Indonesia, and I will present you about our research. The title is Smart Home Prototype for Rain Prediction using Artificial Neural Network Algorithm. Okay, for the outline, uh, the first is introduction, and next is methodology, and next is discussion, and the last is conclusion. Yeah. Okay, we get the introduction. Yeah. Unpredictable weather often disrupt daily activities, such as drying clothes outdoors. Smart home technology offers a solution by automating household systems based on weather predictions. The study aims to develop a prototype using IoT sensors and artificial neural networks, or we call it an ANN, to predict rain and automate a clothesline system. The system processes data from multiple sensors to move the clotheslines indoors when rain is predicted, improving convenience and efficiency in everyday tasks. For the methodology, there are 5 steps of this methodology. The first is design of smart home architecture, and next is data collection, and next is data pre-processing, and next is implementation of big propagation neural network, or we call it BPNN, and the last is system testing. For the design of smart home architecture, there are 4 devices, but for these devices can get the 5 parameters. For the DHT11 sensor, we got the temperature and humidity, and to check the air pressure we use the BMP 180 sensor, and to check the wind speed we use anemometer sensor, and to check the light intensity we check use the LDR sensor. And we call it the brain. We use the Arduino Uno R3, and this servo mini servo connect to Arduino Uno to move the clothesline. After we got the result from the Arduino moves the clothesline using mini servo. Okay, for the data collection, the weather data was collected from January to February 2018 over a period of 18 days from 6 a.m. to 6 p.m. with 30-second intervals. The data includes 5 main parameters like temperature, air pressure, humidity, light intensity, and wind speed. Now, each parameter is measured using a different sensor, and for this device of DHT11 and PMP 180, we got the temperature readings, so we can compare between the DHT11 and also PMP 180. Okay, typically weather data is categorized into 2 classes, rain and no rain. In this study, we employ 2 distinct types of labels, sensor labels and also manual labels. Sensor labels are derived from readings obtained from rain sensor, while manual labels are based on direct observations of rainfall. For the data preprocessing, the objective is to handle issues related missing values, data normalization, and imbalance data after data collection. Nah, and also we implement feature selection, yeah, to determine which attributes influence the prediction process. So the collection of this data preprocessing, we got 4 steps, yeah, for the data preprocessing process. For the handling missing values, we use linear interpolation, and for the data normalization, we use min-max normalization. For the feature selection, we use correlation-based feature selector, or we call it CFS. And for the imbalance data handling, we compare between ROS, SMOD, RUS, near miss one, and ENN. Now, for the implementation, VPNN is implemented into the smart home system, and we handle it using trial and error process to obtain the model. Now, the neural network parameters vary during testing include the number of hidden neurons, while of the other parameters such as activation function using ReLU for the hidden layer, solver Adam, learning rate 0,0802 and the momentum, the value is 0.1 or keep constant. Each parameter is taken from the scikit-learn model using the MLP classifier estimator. Okay, for the system testing, yeah, the user provides input values for the 5 attributes. These values are evaluated using the neural network, and the evaluation results are used as parameters in the smart home prototype simulator to control the actuator. The actuator is a servo motor controlled by Arduino, which operates to move the clothesline. Yeah. Okay, the next is discussion. Yeah, discussion. Nah, we got the up when we do the research when we do the research, we implement we put the smart home architecture in the top of the in the top of in sorry in the top of the our house. Yeah, uh, I think the height is 7 meters. Yeah, from the bottom from our house. Yeah. Okay, and we got the 20,000 weather data records were collected, consisting of 5 main parameters. Now, for the data preprocessing, yeah, we use the linear interpolation technique to check the missing values, and we implement the interpolate function from the Python. And for the data normalization, we use data rescaling, and we implement the library from the Python. We call it the min-max color. Yeah. And for the feature selection, we implement the CFS from the Weka, and we got the result. We got the result from the rank of the parameters. The top rank is humidity, kelembaban udara, and next is temperature, suhu, and the next is light intensity, and the next is air pressure, and the last is wind speed. Yeah. Okay, for the handling implements data, we compare some algorithms such as ROS mode, ROS, near miss one, and ENN. Now, from the data, we split into two sets. 75% for the training set and 25% for the testing set. Nah, to handle imbalance data, we use the imlearn library from the Python also. And for the implementation of VPNN, we use the research CV from Python with the MLP classifier estimator. And the best parameters and accuracy scores were obtained based on ANN process applied to these parameters values. Two label types, sensor labels and manual labels, were compared to identify the optimal neural network parameters and structures for each label, yielding the best accuracy. Now, for this research, we got the result. Yeah, we got the three hidden layers. The first hidden layers, we got the three nodes, and the next hidden layers, we got two nodes, and the last hidden layers, we got the four nodes. This is the optimal result. Yeah, after we do the trial and error process. We got three hidden layers like this here. From the left side, there is 6 inputs because there is four sensors, but we got the temperature two from the HT11 and also BMP 180. And the right side, there is only one output, yeah, because we will get the result of rain and no rain. Okay, for the system testing, we develop the UI simulator program to input the value, temperature, air pressure, humidity, wind speed, and light intensity. And the right side is the picture of smart home prototype for rain prediction. Okay, conclusion. Okay. This research successfully created a smart home prototype that predicts rains using artificial neural network. The system effectively classifies weather condition as rain or no rain. And accuracy, the result of accuracy is 86%. And the NN model was fine-tuned using the BPN algorithm, achieving optimal architecture with 3 hidden layers and specific parameter settings. Overall, the findings highlight the effectiveness of the proposed system in real-world application. For the future research, I think meta-heuristic algorithm are a promising option, yeah, for improvement because they are simple. They are simple, inspired by natural process and flexible, yeah. These algorithms can help improve performance by avoiding local optima, benefiting the prototype and similar system. Okay, thank you very much for your attention. If there are some question, please ask to me. Okay, thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.